Hi guys, so this video is on statistics. One thing I want to point out, please pause the video to copy down these definitions. But there's one definition, residual plot, that we did not talk about during this unit. Everything else we did. And we're going to talk about residual plot on the next page. Alright, so let's get started with example number 1. So I see that I'm given only one set of data, so I'm going to go ahead and use my calculator for this. So please excuse while I change orientation. Alright, so where do I go in my calculator? I go to Stat, Edit, and since I only have one set of data, I'm only typing into L1. And to save time, I already typed it in for that. Okay, so if I want to get data, I'm going to go to Stat, Calc, and I only have one variable. So that's what the first one means. One variable. It's only one set. Alright, so now I have all this pieces of information. So let's try to remember what these are. My mean is that first one, that X bar. So our mean is 2.9. So for mean, that's the same thing as X bar, which was 2.9. Alright, our median, we're going to scroll down. I see my median is 3. Mode we can't get from calculator, so I can't do that. Range we'll do in a second. Let's fill out the rest. So I have min is 1. Max was 5. Q1 is 2. And Q3 was 4. Alright, so how do we get our range? Our range is our max minus the min. So in this case, it is 5 minus 1, which is 4. Interquartile range is Q3 minus Q1. Ah! Okay, and the mode is the number that repeats the most, or that we see the most. So I just have to scan my data for that, for any repeating numbers. So I see a lot of 3s. I see 1, 3, 2, 3 of them. Do any other numbers come up 3 times? No. So this is 3. This is the one we see the most. Alright, so now I use that data to construct a box emitter, but I only need 5 pieces of data. I only need the min, Q1, the median, Q3, and the max. Okay, so when we plot those, I'm going to plot them above the line. Alright, we make our whiskers at the end, and then our middle 3 turn into a box. That's where it gets its name from. So this is our min, Q1, our median, Q3, and our max. Alright, next page. Alright, so now I am given an X and a Y. So I am going to go back to my stat edit and type this in to L1 and L2. Alright, because now I have 2 variables. So I'm going to go ahead and do that. So we go to Stat, Edit. I'm going to clear this out. And I'm going to go ahead and type my data. Alright, so all my data is typed in, and I'm looking for the correlation coefficient. So I go to Stat, Calc, linreg, and I hit Enter. Alright, I don't see my R, so I have to fix my calculator. This should be done before your Regents exam, but if you forget, you go to second 0, and then we got to turn our diagnostics on. So I can get my linear regression if it's off, but I can't get the correlation. So let me do that again. Alright, so now I have my correlation, which is the R, which is 0.95166. And it says to the nearest hundredth, which is 2 decimals. So it's going to stay 0.95. Alright, what does this suggest? So is it strong or weak? So the relationship is strong or weak between tutor hours and test score. So I always state what the X and Y's represent. So what is this relationship? 0.95. That is a strong relationship. Okay. Now it wants me to write the linear equation. I also have that information from my calculator. So A was 6.32. And B was 22.428. So that one is going to round to 22.43. All right. So now when I write my equation, I'm just substituting those numbers in. All right. And that's that. So, residual plot. We didn't teach this to you then, but it is so easy. That's why I'm going to just teach it to you now in the next minute, and that's it. It's that easy. That's why we don't waste time in class. So, when I'm talking about residual, I can ignore the y value. I only need the x and the residual. All right? And basically, residual is like how far it is from the predicted equation. So this is our predicted equation. This is called our line of best fit. So if I plotted this data falls in the best possible place for it. So I'm going to plot those points. So 1, 1.3, and I'm just estimating because it's decimals. 2, 1.9, 3, negative 6.4, 4, 5, 2, 6, 6.6. Okay, and basically here's what you need to know about residual. The residual plot tells us if the equation is a good fit for the data. If it is a good fit, it means the residuals are scattered. Okay? If it is a bad fit, it means the residuals, as shown to the right, are in a shape. So maybe the graph looks like a U. Or maybe it is, there's some sort of shape forming with the dots. So when I look at these residuals, is there any shape forming or are they pretty scattered? These are scattered. So if it's scattered, it means it is a good fit. So the equation is a good fit for the data. What that means is my line of best fit is pretty close to the actual data points. All right? And that's all you need to know about residuals.